All right, so the purpose of this video is to discuss Physics Classroom Calculator Pad EC15, electric circuits. As you're doing EC15, it starts off and it asks, what would resistance be if some resistors are connected in series, if they're connected in parallel. Gives you the same ones, calculate that. This should refer back to your notes and equations. You should understand how to do this. I'm not really going to show that right here. Um, if you're struggling with this, you need to go back and work on some of the previous assignments again. This question number 2 here shows them different ways, and it says the equivalent resistance of each collection of resistors is indicated by a letter. Determine the equivalent resistance associated with the collection of resistors. So basically, we have a bunch of letters here, and it's saying, well, what is the total resistance in all of these scenarios? So like in this one, it would be 4 plus 4 because they're in series. This one, it would be 1 over 4 plus 1 over 4 inverse. So remember, 1 over our total, we would use our equation that we have for connecting when they're connected in parallel. Here it gets a little trickier. So this would be this one. First, you would have to solve what this is, which you actually just did here. So whatever this value is. And then you would have to add the total of those two together that are in series. You would add those together with 4 plus 4. So you would find that C would actually be equal to 2 in this scenario. And so then it would be 2 plus 4 plus 4, or this one would be 10. If you continue across, this would be 10 here. These would add together. This would be the inverse of 1/4 plus 1/8. And then this would be 4 plus 8, 12, plus the result of whatever that is. And this one would be something like 2 2/3. So that is where we're at here. If we keep moving down, I had a lot of questions about this one. Really, this is no different than what we saw up here, but I'll try to um, we'll jump in and take a look at this. Sorry, that's the wrong thing. We'll jump in and take a look at this one. I saw quite a bit of questions about this. And so really all this is saying is it's important to realize that these two resistors here are in parallel with each other, because as the electrons would come here, they have an option. The charges can split and go two ways. It's important to note that those electrons come back together after here and travel around. And so these two resistors are in series with this third one. So the first question here, let me change this color because we're getting a lot of red on there. This first question, it says R4. It's really just wanting to know what is the total resistance of these two, which you've got to go back to your equation of 1 over R total, and you add up the inverses and get the inverse of that. So this one would be, you would solve that by 1 over, since you have 27 and 27, which are these two. R4 is going to be the total of that. Then when you get to R5, it's going to be R4, which you solve up here. It's going to be R4 plus R5, because remember, when resistors, that's really sloppy. Let me fix that. When resistors are in parallel, they add up like this, but when they're in series, remember, R total is just the sum of them. So in this case, it would be R total for 5 would be R4 plus R3. And that's how you would get this one.